All right, guys, in this video, I want to talk about my vapor blasting prototype gun right here. So you saw a previous video right here of me designing it in CAD and then printing it. And this is actually a functional unit. I can throw it. It's actually wet because I just got done blasting with it for some clips. But anyway, this is a functional gun. We're going to throw in the cabinet. You can see how it works. And then I want to talk about the next steps, which is actually, you know, mass producing it and selling it to you guys so you can have a really nice gun to go with the cabinet that you all probably built, right? All right, so let's go over to the workbench. I want to talk about like the first gun I used and what some of the retail cabinets come with, and then the Tacoma gun, and then finally this guy, okay? Okay, so let's talk about some of the guns that I've used and are available in the marketplace. And this isn't all of them. There's plenty of guns out there, but this is what's most common. Okay, so first off, this is the gun I started with. This is the same thing that like retail cabinets come with. This is a $35 gun. Heck, you could probably even get it for $20 depending where you get it. This thing has a bunch of pros and cons, so let's quickly go through it. First of all, you have to change the fitting out. It comes with a 1/2 inch fitting. It's best to go to a larger size, okay? The price is pretty much the only good thing about it, okay? Let me explain. This nozzle here, see how it's off center? It's just poor quality, okay? It's not centered relative to the air jet, and right off the bat there, it loses efficiency. It's very bulky. The body's pretty big, and the blast pattern is pretty scattered, so it's hard to see what you're actually doing compared to these other guns I'm going to show. And another thing, it has a chamfered nozzle entry. So if you think about it, all the slurry's here, and it's trying to exit out the nozzle, right? So it's going, takes a sharp turn, and another sharp turn, and then exits. And then the blast pattern, as a result, is very scattered. These guns here very much so smooth out the flow, okay? And that gives you precise blasting, and also the media is traveling faster, and therefore it cleans faster, okay? It's just more efficient that way. Okay, regarding the nozzles, this is the nozzle from the cheap gun, and you can see it's only about 1 inch long, okay? It has a straight bore. Any nozzle that has a straight bore, I can tell you that it will be inefficient, okay? So there has to be a little bit of geometry in here that smooths out the flow, okay? So not only this nozzle, but you see the pink ceramic nozzles that you get with the Harbor Freight guns and other cheap blasting guns. That's a straight bore as well, and it's inefficient just like this one, okay? So you can see here that the nozzle I have is roughly double the length, and it is straight. It does have a straight bore towards the end, but from here to here, you know, there's a transition period that really makes a difference in the flow, okay? So that's one benefit of running a better geometry in your nozzle. Some parts in here, like this guy here, begins to rust, and you know, that's obviously an issue. You have rust now collecting in your air passage. I've ordered about 6 of these guns for all the testing I have done, and sometimes most of the time I get them with the incorrect size parts, okay? There is zero precision to this. Who knows who is assembling this, and you may get a gun that has mismatched parts, okay? There's a certain size for this guy in here relative to that guy, and I've received numerous ones and they were incorrect. So actually in my plans, I have some information on how to check all that, because obviously you're not going to get a quality piece here. The machine quality of this, you know, this guy needs to be concentric to the jet. Simply put, I mean, how could you have an offset hole and expect this thing to work well? Also, if this thing's advertised as 8mm or whatever, it's usually like 0.5 millimeter under or whatever, and that really affects the performance, okay? So, price point is good. It has a boron carbide nozzle, which, you know, that's the best material for a nozzle, but it has a lot of cons. I mean, this gun runs at 50% efficiency, Okay, if I claim that this guy here is 100% efficient, this is 50%. Okay, this guy here is twice as fast. Okay, next up we have the Tacoma gun. This is a great gun. The only problem is it's hard to get. Okay, and what I mean by that is it's not listed on a website. You can't just add it to your cart and buy it online. You have to physically pick up a phone and call and talk to someone at Tacoma to place your order. And that's an issue for a lot of people, apparently. And I don't think he responds well to emails. He may not answer the phone. So I get at least 1 to 2 emails a week or messages. Hey, I want that yellow gun. Where do I get it? And I say, you gotta pick up the phone and call, man. Moving back to this one. This is a dry blast gun. Okay, it just so happens it works in vapor blasting. This is also a dry blast gun, and it works great for vapor blasting. Some things I would like to change about this is, see how it only has 1 barb for the hose. I like to see multiple barbs because that's multiple bites on the hose and multiple sealing tiers. So I went ahead and did that on mine as well. Another thing is this inlet is pretty small. Okay, it's an oddball size because it's for dry blasting. So 1/2 inch is really tight. 5/8 is loose, so you have to really clamp it. Okay, the Tacoma gun, we talked about the small fitting. It's for like a 1/2 inch, 5/8 hose. Here we have a much larger hose diameter that we can run. And one thing that this makes you do is downstream you have to run smaller fittings because it's a smaller hose, and smaller fittings obviously neck down the diameter, and therefore it's a restriction. Okay, and it's not ideal to have any restrictions in vapor blasting because we are pressure feeding the water or the slurry into this fitting. Okay, so you can see how much larger my fitting is here, and it has a huge chamber area to have that slurry ready to go to exit out of the nozzle. Okay, so that's one benefit of going to this gun. This body and nozzle nut, after you run this guy for a while, it gets jammed up with media, obviously. And when you get media in between threads, it's hard to take apart. So you can see there's some marks on here. Sometimes I have to put this guy in my vise and then use some pliers to break this guy loose. Okay, so I would like to see, like what I did here is I have flats, and then I have, you can put an adjustable wrench on this to loosen this guy. Okay, so that's something I'd like to see. Okay, other than that, this gun is great. It's very ergonomic. I really like the skinny tip here because for, let's say you're dealing with cooling fins, or you're dealing with like, real small tight spots like this, like these casting webs. I mean, this thing here, it's just very bulky and you can't really see what you're doing. So I really like the skinny tip in front. Okay, so those are these 2 guns, right? There is a vapor blast company out there that sells, I inquired, they want $500 for their gun. And you know what? I don't know what makes it so freaking special. In the videos, it doesn't seem like it, the blast pattern is all that great. It's pretty much like this one. I think it has a check valve in there, but $500, that's crazy. I'd rather have this gun. This gun looks like it blasts better. $500, that's crazy. Okay, so let's talk about my gun here. This is a prototype 3D printed part, and here's what I did. Okay, first of all, huge slurry inlet, huge chamber, and all these transitions in here are very smooth and not sharp like you find in this gun. This one has good transitions as well. So, super smooth transition for the air, super smooth transition for the slurry, and ultimately what that does is just gives you good flow. Okay, it's pretty ergonomic. Let's put some hoses on here. So you got a hose here and a hose here, and I made these fittings really tight so that way you just put zip ties on there. So it just fits right here in the crotch of your fingers and right there, right? So that's what I was hoping for. Let me get these freaking tubes off. Alright, so let me take this apart. What's crazy is this is 3D printed. I even modeled in the threads. And the threads work great. I mean, so that's a slurry fitting there. Slurry input. This here is the air jet. Okay, this is going to be made from brass. This is going to be made from brass. And what I have done in here, which you can't see if I was able to show you cross section, is it really tapers and smooths out the flow. Okay, and that is a specific size to consume a specific CFM. This here, this nozzle nut, brass as well. This guy here, aluminum, and it'll be anodized. So what's cool about anodizing is it'll get all in here and it'll protect it from corrosion. Okay, so not sure what color yet, but anyway. Now for the nozzle, I got a couple O-rings on here for sealing, some super secret sauce geometry for this for the flow here, and I plan on making this from hardened stainless. Okay. This one here is boron carbide. You got ceramic over here, and I'm planning on hardened stainless. So as far as the wear properties, let me tell you something. I built 2 machines, logged over 30-40 hours of vapor blasting total, tons of different guns. I keep testing stuff. I have not wore out a single nozzle, nor have I been able to measure any wear on any of my nozzles. Now I mainly run fine glass bead, but I do run some aluminum oxide. And just so you know, I've been running this 3D printed part. I've been blasting with it for hours with fine glass bead, and there is no wear on a fake 3D printed part. Okay, so I am confident that a stainless nozzle will suffice. Okay, and it is a wear item. You will have to replace it at one point. Okay, so that's pretty much it. I mean, this guy, what I'm hoping to do is produce it, have it on my website, so you can click buy, I'll ship it wherever, and that's it. And it'll be a high quality, precise blast gun, because precision is where the performance comes in. And same with the nozzle geometry and all that good stuff. And you're going to get parts that work together well. I've done tons of testing on what all this should be given a certain CFM available. Okay, so I'm going to have this available in a couple different sizes. I'm hoping 5 horse, 7.5 horse, and 10 horse. Okay, those will all consume a different amount of CFM. I will test it on this part here because that's what I have. This thing is very nasty, and it would probably benefit from a coarser media, but I got fine glass loaded in there, and you know, this is really corroded, and that corrosion is the hardest stuff to remove, to be honest. So Okay, real quick. So that was the 5-horse version, 7.5 version, and the 10-horse version. Now you're probably thinking, Matt, how are you doing 10-horse if you only have a 5-horse compressor? Because yes, I only have 17 to 19 CFM available. Okay, so what that means is I can run this gun here in the 5-horse configuration continuously, and my compressor keeps up. It actually turns off, which is good, right? If I run this guy, obviously it's draining it faster. And this guy, oh my god, dude, this is a 37 CFM consumption at 60 psi. So I can run it for about 2 to 3 minutes, and then it drains the tank below my working pressure, and the pump can't keep up, okay? So this is a 10 horsepower version. But oh my god, dude, this thing cleans so fast. I wish I had that much horsepower, right? I even want to buy a 7.5 horse one day. So you can see that the components that go in here determine how much CFM it consumes, and you have to have the corresponding nozzle, okay? Now you can't just slam a huge nozzle on a small jet. It won't work, okay? The velocity will be too slow and it's not going to clean, okay? So this is all match set, and I played around with this extensively. I mean, man, I started making all kinds of nozzles, changing the geometry, changing the diameter to get the optimum size. And I feel like this gives a nice punch with the amount of slurry. You have the air to back it up to get the correct velocity, and it cleans very well, to be honest. And this is a plastic gun. You make this out of metal, all the surface finishes in here will get much better, obviously, and the flow is just going to get that much better as well. So, I mean, this works great for a plastic gun. Out of metal is just going to be freaking awesome. All right, so I finished up this part with this gun set up in the 10 horsepower, 37 CFM setup, and oh my god, it just freaking rips. I mean, anything with that amount of CFM is going to rip, but man, this thing's dialed in real nice, and it cleaned this part really fast, okay? And it's just 3D printed parts, plastic, and it holds up. No wear on the nozzle with fine glass bead. It was done at 60 psi, and yes, I had to stop a few times to let my compressor catch up because it'll completely drain it below 60 psi. You know, I got it set to 60 psi to blast. But oh my god, it'd be awesome to have a 10 horse compressor. So yeah, this is one part for my Chevelle, the LS turbo build, and this is the compressor bracket. And it was really, you know, with all these details in here, you know, getting a gun like this in here is very cumbersome. This guy here, like, look at this deepest one. I just stuck it right in there. You can move it around like that, and it blasts all in there. All that is clean. There is no corrosion in any of those deep spots. So that's one benefit of having, you know, a tapered nozzle like that. Awesome. I'm so happy the way it came out. Okay guys, so if you start off with this gun and you want to blast faster, there's only two options really. It's increase the amount of CFM you have, so get another compressor, or you can buy another gun to run more efficiently, okay? So let's talk about that for a second. How much does a compressor cost that has like 10 more or 15 more CFM? A lot of money, right? If you spend $200-250 on a gun that works twice as fast, well, that's a lot cheaper than increasing your CFM in your compressor. Trust me, because compressors are very expensive, and then you need the electrical requirements to run it and so forth. So obviously, if you want more efficiency, you should upgrade your gun. All right, guys, so we talked about it. You saw it work in the cabinet. So now let me talk about what's required moving forward, okay? So what I did is obviously designed and tested this, and it works great. I made some prints, and I sent it out for quoting, okay? And I got it quoted in quantities of 10, 25, 50, and 100 and whatnot, and it seems like there's a nice price break at around 50 pieces. So if I order this at 50 pieces, the price to you guys is about $250, okay? And I know that's a little more than some guns on the market, and I can strip some cost out of here. Like this fitting, for example, is custom because it looks real nice and everything. I can get an off-the-shelf fitting and it'll reduce the cost, right? This nozzle nut on here is kind of expensive. There's other ways to attach the nozzle. I can work on that, but again, the price is probably going to be $200 if I make those design changes, okay? Still kind of expensive, I know. But to get a CNC machine house to even consider something like this, and you know, their rate's like $100 an hour or whatever, I mean, that's what it is for low quantities, okay? So I don't think I discussed it earlier, but how this would get manufactured is the body would get cut on a 3 or even a 5-axis vertical mill, okay? And then all these other parts, a CNC lathe, all right? So what's nice about CNC stuff is it comes out perfect every freaking time for the most part, right? Versus someone turning one, you know, a one-off in their home garage, right? Okay. So what's cool is I designed this in ProE. Okay. I know some of you are probably asking what kind of software I use and whatnot. So I can export the IGES files. You give it to the CNC people. They program it to your model and they make it to print, and bam, you got a precision gun. And real quick, just so you guys know, I'm actually a mechanical engineer. I have been for 15 years. So what I do every day at work is I design products, and then I make prints, and we send out these prints for quoting to, you know, CNC houses or whatever, and then we buy parts from them. So this is something I do day in and day out. Just thought I'd give you that little info there. Okay, now, if you would like to buy one of these, I would need roughly like 30 pre-orders to even consider placing an order for 50 of these, okay? Because I certainly don't want any inventory of guns, right? I mean, the whole point is to get this gun to you guys. So here's what I did. I set up a pre-order link, okay? It's set at $250 right now, and how that would work is your credit card would not get charged until this thing is produced and ready and tested, and I put a video on it. So this is how it would work. Let's say you pre-order something, you don't get charged a dime. I would actually place the PO for it. A couple weeks would go by, I would get the parts, I would put a nice YouTube video together detailing all about it and the performance and whatnot, and then I'd probably go back to, hey, do you still want this? Let's fulfill this order that you pre-ordered months ago or whatever. So that's how it would work, okay? Now, I know that's asking for a lot at this point, but I need some kind of skin in the game, if you will, right? So, I mean, if you are interested and you don't want to go through the pre-ordering, shoot me an email, okay? Just shoot me an email, or maybe I'll set up another link to put you on an email list, and then we'll have a discussion about what size you want. Maybe there's a size that I am, you know, lower than 5 horse that you want. But basically, that's the process from here on out. I mean, I'm at a point where, you know, I can cut the PO tomorrow and get this thing rolling. So let me know if you have any questions in the comments below. But I think this would be a really nice gun to bring to the market.